Okay. So let's see whatever we write here. Up to now, we had done conversion of one form of the energy to the other form. Today we will see that if you have the potential energy, so potential energy we had studied of two types. We had studied the gravitational potential energy given by the formula mgh. It is given by mgh, and we have spring potential energy or potential energy stored in the spring is equal to 1 by 2 kx squared. Then we have also seen the kinetic energy given by an object. The kinetic energy is given as 1 by 2 mv squared. So today we'll see two things. We will first observe the change of kinetic energy when we will prove that the sum of kinetic and potential remains constant. Okay. The second thing we will prove that the work done. We will also prove that work done is equal to change of kinetic energy. So work done is equal to change of kinetic energy. This is the concept which we'll see and try to solve some numericals. So let's see how we got that work done is equal to the change of kinetic energy. We can see we can have the amount of work done is given by the formula. Work done is given by the formula force multiplied displacement. So we can write work as force times displacement. Force can be written as mass times acceleration. So we can write it as ma multiply displacement s. So this is how we can write our work done. But as per our knowledge of the kinematic equations of motion, as we are aware of the kinematic equations of motion, so we have v squared minus u squared equals 2as. Now from this, if you just take the value of s displacement from here, so we'll be getting v squared minus u squared
by 2s.
over 2a should be equal to s.
Yes,
So we
sir.
can substitute, if we substitute the value of s, so we get something as m a multiply v squared minus u squared over 2a. So a and a cancel with each other. You get 1 by 2 mv squared minus 1 by 2 mvu squared. So here, since v is the final velocity, we can call 1 by 2 mv squared as the final kinetic energy and 1 by 2 mu squared as the initial kinetic energy. So you have here, we can call it as, this is our final kinetic energy and this is our initial kinetic energy. Okay. So we can interpret the work done, we can interpret the amount of work done to be equal to the change of kinetic energy. So if you are subtracting final kinetic energy and initial kinetic energy, you will be getting the change of kinetic energy. Change of kinetic energy is represented as the work done. Right? So work done can be obtained by subtracting the energies, by obtaining the difference of the energies. Okay. So let us try to do one of the numericals which is based on the same concept. A similar concept is applied over there. Yes, Jaswant, are you there? Jaswant?
Yes, sir.
Okay. You see, try to do this question. We have a car of mass 1500 kilogram is moving with velocity velocity of 40 kilometer per hour. So find the work done. Find the work done. Find the work done to increase its velocity. Yes, to increase its velocity to 80 kilometer per hour. So I hope you know what formula to be used.
Yes, sir.
Yeah. So do it. Do this question. A car of mass 1,500 kilograms is moving with velocity of 40 kilometer per hour. Find the work done to increase its velocity to 80 kilometer per hour. Yes.
1 minute.
Yes.
Sir, 2 minutes will be done.
We need to use the formula. The work done should be equal to change of kinetic energy. So we will be using this formula. Work done equals to 1 by 2 mv squared minus 1 by 2 mu squared. So work done is equal to change of kinetic energy. Now, uh, we just need to convert these energy velocities into SI system of units. So you need to use 40 kilometer per hour. This is our initial velocity. Convert this 40 kilometer per hour to meter per second. So convert this to meter per second. You need to multiply this 40 with 5 by 18. So you get 200 by 18, which is 100 by 9. Similarly, convert 80 kilometer per hour. So 80 kilometer per hour would be equal to 80 multiply 5 by 18. So again, it would come out to be 200 by 9 meter per second.
Why is it
Now,
5 by 18?
yeah,
Why is it 5 by 18?
yeah. So earlier I had told you the conversion, how to convert from kilometer per hour to meter per second.
Can you just repeat it?
Okay, see, you have this kilometer per hour. Suppose I write it as 40 kilometer per hour. Now I want to convert it to meter per second. Okay. So I have to convert this kilometer to meter and hour to second. That is what I have to do. So 1 kilometer, as we know, so instead of 40, we'll have here 40. And 1 kilometer should be equal to 1,000 meters. So we put here 1,000 meter divided over second. So here you have hour and the hour should be converted to seconds. And hence 1
3600
hour
seconds.
is 3,600, right?
Hmm.
So if you cancel here, you get 5 by 80, 10 and 36. Cancel 10 and 36, you get 5 by 18. So you get 40 multiplied with 5 by 18.
Okay, sir. Understood.
Got it. So in this way, we are getting here 100 by 9.
Okay, sir.
So every time, whenever you have to convert from kilometer per hour to meter per second, multiply it with 5 by 18. So you will be able to convert. Now we can use the formula of 1 by 2 mv squared minus 1 by 2 mu squared. Okay. Or you can find out the final kinetic energy. You can find out the initial kinetic energy. Okay. So I hope now it's possible. It's simple for you. Yes. You just need to put the values. Work done would be equal to 1 by 2 multiply mass 1500 multiply your v squared minus u squared. Put the values, solve and get the answer.
Okay, sir.
Okay. So final velocity is 200. This is the final velocity. Substitute and get the answer. So I think now it's easy. Just obtain the answer now so that we move to the next question.
Okay, wait for 2 minutes. It is 100 divided by 9.
Okay, got it?
So what minute?
So I'm also solving here. Just you can check your answers. You can check your final answer.
One, two, three. 200 divided by 9.
Is this somewhat you are getting? So I think this should be the answer that you are getting. 25 multiply 25 over 9 multiply 10 to the power 5. Okay. So let's see another one, a little bit different, but using the same concept.
So can you show the previous slide?
Yeah. Just one.
1 minute, sir.
You can do the calculations. You can use your calculator also.
Done, sir.
Done. Okay. So the next question, a little bit similar here. We have again some unit convergence may be required. So a bullet of mass 50 gram is fired from a gun with, or no, sorry, strikes a wooden block. Strikes a wooden block with 200 meter per second. If it penetrates the wooden block to a distance less of 75 centimeter. Find the retarding force of the block. To do it, a bullet of mass 50 gram strikes a wooden block with 200 meter per second. Penetrates a wooden block to a thickness of 75 centimeter. So find the retarding. Okay. So what do you think? What should we use? What method and what formula should be used? Yeah, just one. Pritam?
Yes, sir.
Pritam, any idea which
Sir.
formula to be used?
No, sir.
Okay. If you observe the different things over here, what happens in all. So let's take the wooden block. Suppose this is the wooden block and you have a bullet striking this. Suppose you take a bullet which strikes this. So you take a bullet that comes and strikes this and it penetrates through a distance of 75 centimeter. So the bullet penetrates a distance of 75 centimeter. Now see what happens when the bullet strikes it strikes with a certain kinetic energy. It has some amount of kinetic energy in it. Okay. And that kinetic energy will be equal to 1 by 2 mv square. So when bullet strikes over here with a certain speed, let's say it strikes here with a speed of 200 meter per second. If it strikes with a speed of 200 meter per second, then as it passes, its speed becomes zero. Its final speed becomes zero. So as in this case, we can observe that some work is being done by this block on the bullet to stop it. Okay. And we know that the amount of work done is given by change of kinetic energy. So we will try to find out the amount of work done by obtaining it in the form 1 by 2 mv squared minus 1 by 2 mu squared. Got it? Yes?
Yes, sir.
In this way, we can obtain the amount of kinetic amount of work done and the kinetic energy. Now, as you also know, the amount of work done is given by force multiplied displacement. So we can get the amount of work done by the formula force multiplied displacement. So use the formula F into S to be equal to work done and hence obtain the amount of force. Right?
We
So
should
for
find
this,
the final force.
no, see, this is the amount of work done. So you can obtain your work done to be equal to 1 by 2 multiply mass, which is 50 gram, means 50 by 1000, and multiply by v squared minus u squared. So its final velocity is 0, which we'll be taking here 0. Initial velocity is given as 200 meter per second, so we'll put here. Now, this should be equal to the work done. So work done we are obtaining here 1 by 2, cancel this 0. You get multiply 5 over 100 and multiply 0 minus square of 200 is 40,000. So subtract this 1 by 2 multiply 5 multiply 100 multiply 40,000. So 2 zeros already cancel. Cancel this 2 with 400, you get 200. Multiply 200 with 5, you get 1,000 joule. So 1,000 joule of work is done in stopping the bullet. To stop the bullet, this block is doing a work of 1,000 joule. Now work can also be calculated or work can be obtained by the formula force multiplied displacement. So we can obtain here work done equal to force multiplied displacement, where force F multiplied displacement, which is we know as 75 centimeter. So this will be 0.75 meter. Okay. So work done we already know 1000 divided by 0.75 would give us the amount of force. So As no 0.75 is 3 by 4, so you can put here 3 by 4 of 1000 is force.
1000 by 0.7.
Yeah. Yes, it's 4 by 3, not 3 by 4. It would be 4 by 3. Yes.
Yes, sir.
Okay, it's 4 by 3. Now you can multiply and divide. You will be getting the amount of force that is applied by this bullet.
4
Applied.
divided 3.
Yeah. Now I'm giving you another similar question. Okay.
Yes, sir. It's like
Yeah.
1333.3.
Okay. Yeah, that you are getting. 1333.3 Newton. 1333 Newton.
Yes, sir. You're correct.
Yeah. So this is the retarding force obtained by the block to the bullet. Okay. Now another thing can be done over here. Suppose if you have a bullet of thickness 50 centimeter. Now let's do the same thing. Again a similar thing. A bullet of mass 100 gram strikes a target with a speed of thickness with a speed of 100 meter per second. Then what is the retarding force offered by the target? So what is the retarding force offered by the target if the bullet emerges with a speed of 25 meter per second? So again, a similar thing with a little bit of difference. So I think now you should be able to do this question. Apply the same thing. The similar concepts are used here. So Jaswant and Pritam, I hope you will be able to do this. Can we do this question now?
Yes, sir.
So do you find any way of solving it out?
So I'll try.
Yeah, try it out. Yes, both of you are trying.
Yes, sir.
Okay.
Yes, sir.
Okay. So try to obtain the correct answer for this.
Sir, what do you do with the thickness or the
Yeah.
thickness?
Thickness is the displacement, and that is the complete way through which the bullet is crossing, or that is the complete path when the bullet is offered the resistive force. After that, there is no resistive force. So that thickness is the displacement.
Oh, okay, sir. Okay.
Since it completely passes through it, so that thickness will be the displacement of the bullet against the resistive force. So say the formula to be used. First, we will be using our work done equal to 1 by 2 mv squared minus 1 by 2 mu squared. Okay. So then after this, we'll be using work done equal to force multiplied displacement. So we have here, we can put 1 by 2 multiply mass is 0.1 kilogram. So you have to put everything in SI unit. It will be 0.1 kilogram multiply V square, which is the final velocity of 25 squared minus 1 by 2 multiply 0.1 and multiply U squared, which is 100 meter per second. So this is 100 squared. So taking out common, you have 1 by 2 multiply 0.1. And here you will be getting 25 squared as 625 minus of 10,000. So if you subtract and multiply, get the answer.
Okay, sir.
Then equate the same thing with force into displacement. See, if you equate the same thing with force multiplied displacement, so force multiplied displacement would be 0.5. So you get this displacement at 0.5, which is 50 centimeter. So you can obtain the force. It would be 1 by 2 multiply 0.1 over 0.5 and subtract this. So if you subtract from 10,000, if you subtract 625, you will be getting 9,375. So that should be equal to the force. And this should be 0.1 simply. I think if you cancel this, we'll be getting this
Yes,
point
sir.
and point cancel, and so you get 0.1. So your answer should be 937.5 Newton of the retarding force. Okay. So I hope you have understood the concept that the work done is equal to the change of kinetic energy. Right?
Yes, sir.
Yes. So see, this is one of the concepts which we have where we had seen that work done is equal to the change of kinetic energy. So similar to the in the coming test, Saturday we'll have a test, and on the test you will be getting the topic of potential energy and kinetic energy. Okay, so not only potential kinetic, all the energy and energy transformations that we have done, the same test will be available. Okay. So any doubt in today's class?
No,
Yes,
sir.
sir.
Yeah. So what's the doubt? Yes. The doubt.
No doubt.
Okay. Okay. So bye both of you. I will see you again tomorrow, same
Thank
time.
you for class.